Aloha and welcome to this module on coding standards. I really think this is one of the most important things that you will learn this semester in ICS Software Engineering. The importance of standards in general and coding standards in particular cannot be overstated. It's almost as if you don't use standards, it would be like you have a bunch of people and they're all speaking different languages and you can't understand each other, and any kind of communication is really difficult. So even though you may not agree either in this class or elsewhere with the standards that are enforced, I hope that you will come out of this experience recognizing that adhering to a standard, which is hopefully the standard that you think is best, but in any case some kind of standard, is more important than everybody following their own idiosyncratic style, which they think is best, and creating systems that are this melange of stuff. And it is very much more difficult than it needs to be to evolve and understand and bring new people into. Okay, so in this module, we're going to talk about the motivation for coding standards briefly, just like I already did. And then I want to help you guys learn how to write code that conforms to the standards that we'll be using for the purpose of this class. I want to give you some experience looking at code that does not conform to the standard and recognizing places where there are violations, because that's always very important. And then finally, coming out of this, you're going to be very excited to use tools that help you discover when code does not satisfy the standards, because it's very difficult to see violations actually. I mean, you can see certain ones pretty easily, but having automated support for it is very nice. And we have a good tool called CheckStyle that can look for certain kinds of errors. For the very basic kind of layout stuff, you'll be able to import a Eclipse format style sheet or set of rules into your Eclipse environment, and then you can just do a little propeller shift F kind of thing, and it will automatically format in terms of braces and new lines and stuff your code to conform to the convention. So it's there is tool support to make this fairly easy. And then, the big question is kind of what are these standards? And not all standards are at this low level of just layout of code. There's higher ones as well. Okay, so adhering to coding standards is a key part of collaborative software engineering, team-based system development, because it so immensely improves readability. Okay, and the way it improves readability is that when you're looking at code, you're not tripping over someone else's idiosyncratic notions of where to put braces and how many spaces to indent and all that stuff. It's always going to look the same. So you can focus in on the actual logic and design of the code without being put off by these kind of structural idiosyncrasies, I guess. Okay, and then we can do checks to make sure that basic levels of documentation are always present, and it makes maintainability a lot better because you're not looking at code that looks like it was written by 14 different people, at least superficially. Okay, so what we're going to use as our basis for standards in this class is the Elements of Java Style. There you can see it. This is a great book. Okay, I really like this book. It was written a number of years ago. Very well written. Look how small it is. Okay, very small. It's just about, it's less than 100 pages, and each page has, just a couple paragraphs on it. So you should be able to whip through this book in, I don't know, an hour, 90 minutes. What I recommend, it's coming up to Labor Day weekend. You're going out to the beach, you're hanging out with your family. Just tuck this puppy into your pocket. Take it with you to your family gathering, the barbecue at Magic Island, whatever. While everybody else is chilling out, you just hang out with the Elements of Java Style. You can read it really pretty quickly. Okay? Plus, it's actually really well written and kind of interesting. You'll learn about lots of best practices for Java development that you might not have known about before. And it's very easily digestible. teaches you not, it teaches you about documentation, best practices. It teaches you how to name classes, variables, and so forth in an elegant way. It teaches you some interesting kinds of coding level issues as well. So it even gets a little bit into the design stuff. Okay, so this is not it was a required book for the class. Hopefully you all have a copy, and I really want before Tuesday for the next class period for you to have gone through this book and read it. Okay? Read it at least once. You might even end up reading it a couple times. But in class on Tuesday, we're going to do an exercise which requires you to be familiar with the contents of this book. So I really want to see you doing it. Okay? All right, so it's divided into a bunch of different sections: general principles, formatting, naming, documentation, and so forth. And what I'm going to do now is like a little whirlwind 10-minute overview of the book, highlighting various things, but I'm not going to go into any detail. And the great thing about this book is not only that it gives you a standard, like capitalize the first letter of each word that appears in a class or interface name, but it also explains why that standard is interesting and shows you examples that conform to it and examples that don't. So the explanations are really key. Okay, don't just look at the actual guideline, but read the explanation as well. Okay, so there's some general principles, which are kind of just general principles for development in general. That's why they're called general principles. I like the principle of least astonishment, which means you want things to be simple, clear, complete, and consistent. Okay. Try to do things right the first time, and that kind of refers to not going and writing the whole system and then adding comments, not writing the whole system and then adding tests. Try to create your system in kind of incremental layers, like an onion kind of thing, starting very small, but well documented, well tested, reliable, et cetera, and then you kind of grow out from there, but you're keeping it kind of releasable along the whole way. Okay, formatting conventions. For this class, it's going to be 2-space indentation. Again, I'm just going to say that's, even though that's my idiosyncratic, I believe it's better, but there's lots of people who can argue that 4-space indentation is better. We're not going to have kind of, religious wars. Okay, it's just, this will be the standard for the following 4 months. And when you get out, if you can convince your organization that you're working in that 4 spaces is better for your software, by all means go ahead and do it. It just should be consistent, right? We don't want to have some 2-space, some 4-space. And again, the Eclipse formatter will enforce this or automatically format your code this way if you set it up that way. 100 characters per line maximum. Have some white space. Do not use tabs. Tabs are the spawn of the devil. And in Eclipse, there's a setting which will automatically remove tabs and replace them by spaces. Naming conventions, okay? In general, the name should be meaningful. Do not use one-character names. Use names that make sense for the application domain. A nice little heuristic, if you have some really long variable name, maybe that means that your design is a little suspect. You might want to rethink it. If you're a C programmer, in Java, the convention is to actually use vowels. Okay, so you can have them in there. There's a convention that if you have acronyms like XML, which are normally all of them are capitalized, the convention is you only capitalize the first letter. So X is capitalized, ML is lowercase. Even the Sun people who are responsible for many of these guidelines here, even they don't get that right all the time, so it's a little frustrating, but that's the guideline. An important one is that you don't want to have names that differ only in case. So for example, the instance with a lowercase t could be a variable name. The instance with a capital T could be a class name. You don't want to have a class name and a variable name that are exactly the same and differ only in case. It's just a source of potential problems. For packages, use reverse internet domain names. Try to use single words for each package. If you have something like server kernel file system, it's probably not a good package name. It probably also means maybe you're grouping together a number of things that should actually be in separate packages into one package. In a class, you want to capitalize the first letter of each word, including the first word. When you're naming a class, it should be a noun. Okay, that's kind of building off the general object-oriented design tradition. If you have a class that groups together related attributes, then pluralize it. Interfaces should be nouns or adjectives depending on what you're doing. Method names should have a lowercase first letter, and then the remaining words are all uppercase, so get server host name is an example of that. When you're naming methods, you probably want to use a verb. When you're creating accessor methods like get, set, or booleans, you use is, get, and set. That's the Java Bean conventions. Variable names, you lowercase the first word, uppercase the remaining one, so daytime is one word in this particular instance. Okay, for names, we want to use nouns for variables. When we have collections, we want to pluralize them. So you can see here's an array of customers, so that would be pluralized. And then, even though I said in a previous slide that you'd want to avoid, one character variable names, there are certain exceptions to that rule. So if you're using an index in some kind of for loop situation, use I, J, and K. Those are the standards. When you're catching exceptions, it's fine to use the single letter E to indicate the exception that's being caught. And then if you're defining generic types, you use the standard type variables capital S, capital T. Okay, so those are the only situations where not only are single character variable names preferred, but if you don't use them, actually it's a violation of the coding standard. Okay, when you're referring to field variables as opposed to parameters to a method, you want to prefix them with this so that you can tell that it's a field variable or instance variable versus a parameter or a local variable. And as a result of that, when you are assigning the value of a parameter to an instance variable, you should just use the same name, okay? Because that makes it really clear that those things are actually semantically connected. When you have constants in Java, you're supposed to go back to the C convention of all uppercase with underscores between them. Looks kind of grody, but I don't know. That's the standard, okay? According to the book, and we're going to follow it. Okay, so one big thing about documentation. You want to assume that the person that is looking at your code understands Java. You don't have to explain how Java works to people. You explain how your application domain works. Keep the comments and code in sync. Use forceful, clear, concise language. This book, good example of forceful, clear, concise language. It's really well written. I don't know if you've read E.B. White's The Elements of Style, classic book on proper English grammar and usage. This book is a play on that whole idea of E.B. White's book. Okay, documentation should describe the interface between the clients and the users, the clients of a service and the developers of a service. You want to use one-line comments only to explain implementation details that assume that the user understands Java, and you shouldn't be just repeating what the code already explicitly states, but give some insight into the underlying, where or why or how you did it that way. Okay. Document public, protected, private, and package private, basically all the different members you should be providing documentation for. Provide a summary description and overview of each language. Provide a summary description of your application in a file called overview.html. We'll talk about that in class. There's one standard in the book that we won't follow in this class, which is wrapping all keywords with a code tag. That can get to be really tedious, and it's not that necessary in my humble opinion, so we're not going to do that. Okay, for code samples within a Java comment, you need to use the pre tag. That way you preserve the indentation and make the code readable. If you're doing links to other classes and so forth, you can use the @link tag. And write in third-person narrative form, get, sets, allocates. This is hard stuff to actually kind of embed into your brain when you're doing documentation. And I'm going over it super quickly. You've really got to read the book to kind of actually understand it. I'm just trying to give the whirlwind tour here. Each class and package should have a summary description, which is the first sentence of the Java doc associated with a class or method or package, and that should stand alone, because it turns out that when you generate Java docs for your system, you'll see summary descriptions associated with all the packages, with all the classes, with all the methods, and so that first sentence is really key. You've got to write it well. And there's some things about, you know, omitting the subject when possible. You want to try to avoid just an implementation description of what it does, because sometimes what it does can change, but you want to focus on the higher level, you know, either why it's doing it or the kind of the what at a very abstract level, which leaves some room for the implementation, the actual way this thing is implemented to change. So it's more of a design level what than an implementation level what. All fields should be private. Okay, so all instance variables should be declared private. If you need to expose an instance variable to the outside world, then you define a getter for it. This was written prior to Java 5, and so they didn't have enumerations at that point, so rule number 74 talks about that, but that you don't have to do that anymore. There's just an enumerated class. And this is a standard thing to when you have an if statements or any kind of control flow, you want to use braces for both the then and the else to make sure that you don't get errors when someone inserts a new call into the then or else clause later on. When testing for equality, except with situations like numbers or when you actually really want to be looking for instance level equality, you should be using the equals class. Construct objects in a valid state. That's another kind of principle of object-oriented programming. Again, you know, go here for a better explanation of why that is. Also in effective Java, that's a great place to look for that stuff. You can have a set of constructors, multiple constructors for a class, which can call each other. And that's a nice way when you have to have two constructors that do slightly different things with some common code. You can use nested constructors in order to refactor out and avoid duplicating code needlessly. Don't say import java.util.star, because that imports that entire package. Always explicitly import the specific classes that you need. That's important as documentation. So when someone is reading your code, they can look at the import and know exactly what other classes this particular class needs. Now you might say, oh my gosh, I'm using 450 other classes from other packages in this class. That's going to be a lot of lines. And my response to that is, if you're importing 50 other or 100, I mean 50's potentially, 50's pretty a lot actually. If you're importing 75 or 80 other classes, then maybe the class that you're defining is simply too connected to other classes, and you should be refactoring it so that the dependencies are reduced. Okay, in Java we have the notion of checked and unchecked exceptions. Again, go here, you'll learn about it. Also, I'm getting fun. You can go here and get a really good description of checked versus unchecked exceptions. And the idea is you use unchecked exceptions when you want to report on serious, unexpected errors. You don't ever anticipate this happening. Use unchecked exceptions for that. Checked exceptions are for errors that may occur under normal program operation, and that often means an interaction with the user where they type in something that's completely random. That would be rare normal program operation. Okay. Use return values to report expected state changes. Use exceptions to report unexpected state changes, and never silently, just kind of eat a, catch an exception and don't do anything as a result. Okay. Effective Java. Here's that one. Okay. Really great book. I can't recommend it highly enough. Really like this book. This is these two books together. This is kind of, you know, the really easy, simple to absorb version that gets you started with best practices for Java. Then you move on to this one, which is, you know, takes you to the next level. So I really want to emphasize both of these books as being key to your development as a software professional. Packaging conventions, so we want to split our programs into one or more packages. The art of structuring, this is kind of the art of architecture in software design, is how do you design the set of packages, how do they relate to each other. So, you know, here's a heuristic. It just starts to scratch the surface of the things you have to consider when deciding on the packages. We will be, in a couple of weeks, be starting to talk about build systems and automated quality assurance. Then we'll get to check style, which will implement lots of different checks which can help you ensure that your code is going to conform to many but not all of these guidelines. In addition, as I mentioned before, there's a Eclipse source formatter which can take care of a lot of the kind of the layout issues with respect to the conventions for this class. And one of the big things about the Eclipse source formatter is that it inserts JavaDoc templates, which are really nice because it, you know, then you don't have to be like typing / star blah blah blah. The problem is that it will insert these kind of stub sentences which will defeat check style. So check style will think, oh, this is properly documented, where in fact there's nothing semantically useful to the documentation that was generated. So that's a big issue with using the source formatter. You still got to use it, but you've got to make sure that, you know, just the fact that something passes check style doesn't necessarily mean that the documentation was written well. Okay, that goes beyond what check style can do. If any of you want to do interesting research in natural language processing, maybe you could write a cool AI check style system that would read the comments for a system, then read the code. This would be actually kind of cool. And then do this high level, like, do the comments actually document the code in a semantically interesting way and cause, you know, throw a violation if it doesn't. Even a very primitive parser, I think, would provide a lot of value in this way. So there's a good master's thesis for somebody. Okay. The Elements of Java Style, EJS, that contains most but not all of the coding standards that we're going to follow in this class. I've got one additional page on the website which has a few additional things that we want to do for this class, and then we get into things like Robocode. There'll be, you know, a few other things. So depending on the application, there'll be some additional coding standards just to keep us all writing code that's maximally easy for other people to look at, other people to read, other people to extend and maintain, so that really at the end of the day there's going to be a group of people working together on code, and it'll be seamless. When you look at the code that's written, you won't be able to tell which person in the development team actually wrote it, because it's just going to be so perfect. That's what we want. Thanks a lot, and see you next time.